Here's a slightly different kind of question, although it really is the same question, but it changes units on us. So again, we're given a balanced chemical reaction, and that's up here. And in this question, it's how many grams of hydrogen gas are produced from the reaction of 5.4 grams of aluminum with an excess of HCl. So the question's not in moles, now it's in grams. So steps are the same. We start out writing down what we're given and what we want. So in this particular problem, we are given that we have 5.4 grams of aluminum, and what we want are how many grams of hydrogen gas. So we want to end up with grams H2. So let's go back to our flow chart, take a look how the book suggests we proceed. So in this particular case, we're given mass. So grams, we have to use moles in any stoichiometry calculation. So the first step is going to be going from mass, in this case of aluminum, to moles of aluminum. Once we're in moles of aluminum, we then go to moles, in this case of product hydrogen. The question asks for how many grams of hydrogen. So once we're in moles of hydrogen, we then have to go up to mass of hydrogen. So the way this would look when we write out one of our maps we like to use is grams of aluminum has to first become moles of aluminum, which then has to become moles of, in this case, H2, which then has to become grams of H2. So grams becomes moles, moles becomes moles, moles goes back to grams. Now to do this problem, we're going to need to use conversions that go back and forth between mass to moles. And so I've written down here the atomic mass of aluminum and the molecular weight of H2. So to proceed with this problem, we write down first with what we're given, 5.4 grams of aluminum. Now what our map tells us is that needs to become moles of aluminum, so we're going to multiply by a conversion factor that puts grams of aluminum on the bottom so we can cancel those units, and we want to be left with moles of aluminum on top. We're now in moles of aluminum. Our map tells us we have to have moles of H2, so we're going to multiply by another conversion factor. This time we put moles of aluminum on the bottom, so we cancel those units, and we want to be left with moles of H2, so that goes on top. Now we're in moles of H2. Our map tells us we have to become grams of H2, so we're going to multiply by something that cancels moles of H2 and leaves us with grams of H2. So our moles of H2 cancel, and our answer then ends up in grams of H2, which is what we want. So now what we need to do is go back and find out what these correct ratios are. This first ratio has to be in grams of aluminum per mole of aluminum. That's the atomic mass of aluminum. You look that up on the periodic table. And for every 1 mole, there are 26.98 grams. Over here, same thing here, grams in 1 mole of H2. That is 2.02. Notice those units are consistent on top, grams on top, so it's 2.02 per 1 mole. And then the last thing we need are how many moles of H2 are there for every mole of aluminum. That comes out of the balanced chemical reaction up here. So we've got 2 moles of aluminum will give us 3 moles of H2. So 2 moles of aluminum down here, 3 moles of H2. 3 moles of H2, 2 moles of aluminum. Our units are correct, so the last step we have now is just collecting and doing the arithmetic. So we just collect those numbers, 5.4, units are all canceled, so times a 1, times a 3, times a 2.02, and our units that we end up with here, the only ones left are grams of H2. And then on the bottom, we simply collect these, so it's 26.98 times a 2 times a 1. And if you do that arithmetic, what you find out is that your calculator will tell you 0.6064449 grams of H2. We look back to find significant figures. There are only 2 in our mass that was given to us. This can only have 2, so that ends up being 6.61 grams of H2.